Hello there. This is the next Jamovi activity that we're going to do for analysis of variance. And what we're going to do first is a one-way analysis of variance with three groups. And then we're going to expand that a little bit and talk about a 3x2 design where I have two independent variables, one with 3 levels and one with 2 levels. So let's get started. This is pretty straightforward. First of all, let's go into Jamovi. And fire up the cloud. So let's get started with Jamovi. What we want to do is open up a file here locally on the computer in the Learning Statistics with Jamovi file. There are two directories in here. One is our data sets and one is Learning Statistics with Jamovi. So let's go into here. And I want you to come down here to the data set called Clinical Trial. And the first way we're going to do this is we're going to look at the effect of 3 different drugs on gain and mood. So notice here in our variables, we have some categorical variables, drug and therapy. These aren't numbers, they're labels, they're categorical variables. And then we have mood gain, which is our continuous variable. So the first thing you want to do when you're thinking about doing an analysis is to do this descriptive statistics. So let's go into the exploration and descriptives. And what I want to do is to split the descriptives by the different drugs that are given. And the variable I want to take a look at is mood gain. And here we can see we have 6 people in each group. There's no missing data. And we see the means and the medians and the standard deviations for those. Okay, those are numbers. Let's pop downstairs and look at some plots so we can figure out what we're looking at. The easiest things to do visually are to take a look at a box plot. And we see that the 3 drugs that are given seem to look pretty different. The anxiety-free and the placebo scored kind of the same, and then this joyzepam drug really results in a lot of mood gain. Just for fun, we can also make this a violin data plot, and we can indicate the mean with a little box on it. And this shows us graphically what the patterns are. It seems that this joyzepam drug does have a kind of a skewed distribution with it, whereas the anxiety-free, anxiety-free, and the placebo groups look a little more symmetric, right? Now we're ready to go upstairs and do our analysis of variance. In previous analyses, we just did something called a t-test. That's for comparing 2 groups. And now the statistic that we want to do is going to answer the question, are there any differences among the 3 groups that we have? So we'll come up here to ANOVA and select one-way ANOVA. At which point our dependent variable is still mood gain, and the variable that we want to have as a grouping variable is the drug that is given. And then downstairs, you see I have something called an F statistic now. That's a little bit like the T statistic. And the T statistic had a number and then degrees of freedom that indicated kind of the sample size. The F statistic has 2 degrees of freedom with it. The first degrees of freedom indicates the number of groups you have -1. So because we had 3 groups, this F statistic is based on a 2 degree of freedom F. And the denominator is based again on the sample size. So if you're doing a straight analysis of variance, you're assuming that the error variances inside each of our 3 groups are equal. That's called a Fisher's test. And that's what you see down here, 2 and 15 degrees of freedom. We had 6 groups in each, that's 18. We had 3 groups, 18 minus 3 gives me 15. But the vagaries of what this number is, we don't need to get into. What we're doing is the analysis. and the conclusion. So I have an F statistic of 18.6 with 2 and 15 degrees of freedom, and it's highly statistically significant. If I don't want to assume that the amount of variation inside of each of the groups is the same, I would look at the Welch's test, which gives me kind of the same thing. Remember when we were doing the Welch's t-test, it also had a fractional degrees of freedom. So now we have answered a question. Taken all together, these three variables have some differences in means, but we don't really know. Is it because joyzepam is different than anxiety-free and placebo, or is anxiety-free and placebo different as well? To do that, we're going to have to do something called a post-hoc test. So we come down here and we click the post-hoc test button. And just as with assuming equal or unequal error variances, we have a couple of options here for doing our tests. And over here, I can, in addition to the defaults, I can click this little button that says flag the statistically significant comparisons. So what we're looking at here is now the difference between the means. So on this first row, anxiety-free scored minus 7.67, lower than joyzepam, and anxiety-free scored 2.67 higher than the placebo. That matches our anxiety-free scored higher than a placebo, and it scored lower than joyzepam. Secondly, all right, so that's comparing anxiety-free with the other two, and then I can compare joyzepam with placebo. Well, that scored 1.033 higher than the placebo. So it's 1.33 higher than the placebo here. Now, if you want, there's also the same test for the equal variances. It gives me the same conclusion, but the default here is, assuming unequal error variances is not quite as rigorous of an assumption. It's not quite as strict of an assumption. And that's it. Those are the overall test of your one-way analysis of variance and the follow-up tests as to which post-hoc tests are different than others. All right. Let's move to part 2 now. Notice that this study actually has two independent variables. It has a drug condition, and then we have, did they receive therapy or not? So underneath the therapy column, we have no therapy and cognitive behavioral therapy. And there's some literature that suggests that cognitive behavioral therapy, when matched with an appropriate medication, is even more effective than just having the medications. Possibly, the particular medication that you have might be especially effective with cognitive behavioral therapy. So now what we're going to do is a 3x2 analysis of variance, the three levels of drug, placebo, anxiety-free, and joyzepam, and the two levels of therapy, no therapy versus CBT. Well, just as we did before, it's always good to come in and explore our data. So now what we want to do is we want to put therapy in and also drug level in. And our dependent variable is mood gain. And now we see the same information as we saw before, but it's broken out now by each of these 6 groups. Cognitive behavioral therapy, 3 levels of drug. No therapy, 3 levels of drug. Down here we see our means, our medians. And just as before, we can do box plots and violin plots, and we can put the mean on those plots. Takes a little while to cook because that's a lot of graphing to be doing. But here's what we have. Anxiety-free, joyzepam, and placebo for the CBT group, and the no therapy group. And looking at this, it looks like in the no therapy group, the scores are a little bit lower than they were in the CBT group. So even without medication, the people taking Anxifree seemed to be doing better than the people in the placebo condition, right? And as we noticed before, gee, it kind of looks like these variables are skewed. The joyzepam group is positively skewed. The bottoms are relatively thick down here, and the tail of the distribution lays up at the top, right? Part 2. Now we're going to do an analysis of variance. So now, instead of a one-way ANOVA, we're going to do ANOVA. And our dependent variable is still going to be mood gain. And now our factors are going to be drug as well as therapy. Now what you're seeing down here in the analysis of variance table is a little more complicated than we saw for the first example. I have an F for the main effect of drug, the main effect of therapy, and the interaction of drug by therapy. The first thing I might want to know is, gee, this is just 6 people in each condition. Are any of the means different in anything, given that I only had 6 people? To see that, I'm going to click the overall model test part. And we see overall for the model, I have an F. It has 5 degrees of freedom on it and 12 degrees of freedom in the residuals. 5 and 12 degrees of freedom. The F is 15.4, and it's highly significant. These mean squares, you don't need to worry about much now, but I can't resist telling you that this mean square is the sum of squares divided by its degrees of freedom. But the important thing, take-home message is this 15.4 tells me there's something in there. I don't know what it is. Is it just one main effect or main effects in all the interactions? But I know that I can proceed. I have something in there as a significant difference. And down here, I see a main effect for drug. That's an F with 2 and 12 degrees of freedom. And it is also highly significant. The F is 31.7. Fs under the null hypothesis are usually going to be a number around 1. Downstairs here for therapy, I have an F with 1 and 12 degrees of freedom, and that F is 8.58, and it is significant. The p-value is 0.013. Now for the last one, drug by therapy interaction. Is there a difference in the differences between therapy groups as a function of whether or not they got therapy? A difference in the drugs, sorry, depending on whether or not they got therapy. And here we see that's not statistically significant. So in terms of statistical significance, it looks like so far we have 2 main effects and no interactions. So if you're wanting to take a look at those individual means, I can put the drug and the therapy group in there. And this will give me an idea of what the patterns of the main effects and interactions are. And we can see that overall, the CBT means across the 3 levels, 3 different drugs, are a little higher than the no therapy group. And in both of the groups, it seems like the joyzepam group is a little bit higher than the anxiety-free and the placebo group. And this difference in anxiety-free across CBT and no therapy is not statistically significant. If it was, we could say, oh, gee, maybe people doing CBT with this particular medication are doing significantly better than they would if they did not get therapy. If you want, you can also generate a table of the marginal means. In other words, this is a picture up here, and downstairs we have means. And we can also get the confidence interval on each of the means for each of the drugs within the different conditions to get an idea of what the differences look like. That's it for this class. That's how to analyze a 3 by 2 analysis of variance. If you have any questions, let me know.